Hi, Mackenzie. Thanks for the question. So maybe in class we didn't make it very clear. This is the general rule for a circle, and this is the general rule for an ellipse. And with that ellipse, we end up with it going from negative A through to A and up to B and down to negative B, and that's what our ellipse looks like. So we used r cos of t when I had a circle. And if you think about rearranging the circle is x squared on r squared plus y squared on r squared equals 1, which is the general rule for an ellipse. But of course, r squared and r squared is the same, so it's being dilated away from the x-axis and away from the y-axis at the same rate. Therefore, you end up with a circle. So if this is the replacement that I make when I've got a circle, x equals r cos of t and y equals r sine of t, when I have an ellipse, then I could say that x equals a cos of t and y equals b sine of t. So instead of just having an r there, the a is the square root of the denominator underneath the x squared term. So to look at the question that you just had, if I rearrange this to 2x squared on 12 plus 3y squared on 12 equals 1, that becomes x squared on 6 plus y squared on 4 equals 1, which is x squared on root 6 squared plus y squared on 2 equals 1. Therefore, using this same logic, x is going to equal root 6 cos of t and y is going to equal 2 sine of t. That's 2 squared. As a different explanation than what I did in the worked example where I took the general rule for an ellipse, I rearranged it for x squared and for y squared. I hope that helps.